So I want to open up to anyone come up with any new questions they have about map/collect over their break. And you just all right. Katie.
Okay. So my question, Mike, it kind of ties back into the warm up. So I went back and for the Dynasty 1, I put .map in there instead, and it worked perfectly fine. But my question is, when I had the .each, I realized I didn't have empty like array or something, a collector array outside of the method. Why was it still able to return, or why was I still able to get what I expected, the Kennedy back?
So the idea is that like you didn't need the collector because you didn't want to return Kennedy in an array. You just want to print it out to the screen.
Oh, okay, right.
So we weren't, you could have still had the collector. You could have still done that, but it's like it didn't really matter because we weren't using it.
Okay, so because I had the puts letter in there, it just
it just printed it out. It didn't really do anything else with it, right? And the idea is that you may not need the collector for everything.
Got it.
Like that is a case where you don't need a collector, where you just want to print everything. You don't need a collector because like why you're not doing anything.
Yeah, exactly. Okay, got it. Thank you.
Yeah. So the collector is a pattern, is a common pattern, but again, not the only pattern. Chris?
Yeah, I just wanted some clarification just to make sure that .collect, it is the same thing as .map.
Yeah, I was just going to do that. I was going to do this. So what I'll do here is that I will same exact thing. They're use them interchangeably. But I just use map because like 4 letters less. Cool. Anything else before we move on? All right. Where did I put my notes? Yeah. So one of the, like I've mentioned this before, like one of my favorite things about Ruby is that like just from the method's name, you could probably figure out what something's going to do. Like maybe map collect is not as intuitive as others, but like we've seen methods like upcase, downcase, capitalize. It's pretty easy to suss out what that is going to do. So we're now going to talk about find/detect. And let's see here. Doug, what do you think find does? Just by the name alone, what do we think it does?
It's going to go through your collection and it's going to find the first thing that matches what argument you pass in.
Yeah. It's going to find like a thing we're looking for, right? And so what I'm going to do is I'm going to copy and paste implementation of this with each. And so this code here is like, let's say we have an array of numbers and we want to find the first even number in this thing, right? And so what this does is that we're going to go through this collection of our good friends 1, 2, 3, 4, 5. And so this is a little different configuration than what we've seen in the past. This configuration of the if like this is known as a guard statement. Like it guards against condition. And what happens here is that when Ruby sees this, it will run whatever is on the left side of the if the right side is true. So let's kind of walk through this. We're going to go through. Numbers.each do num. What's the first number? It's going to be 1. I'm like, cool. So we get to this line. I'm like, okay, is 1 even? 1 is not even. This will return false, so nothing happens. We go back through. We get to 2. All right, cool. Num is now 2. Is 2 even? 2.even. That's going to return true. So it is going to now return 2 because num is 2. And then because we have the return statement here, that breaks execution. It will return this to 2. So if I just do a puts find me first even here, and I run it, I'm going to expect that this is going to return me a 2. And it does. So what is the difference between the return value of this and the return value of what we generally expect with .each? Dominic?
The difference, I'm sorry, can you repeat the question?
Yeah. What is the difference between what we're doing here, like what we're returning here, and what we're returning with .each?
I'm not sure what you mean.
So what does this method return?
That's going to return the first even.
Yep. And what class is that?
An integer.
Yep. An integer. And what class is the thing that .each usually returns?
A new array.
Not the new array, the
Or
original.
the old array, sorry.
Yep.
Yeah.
Mm-hmm. So we see here that we're starting to see a significant difference here, right? With .each, .map, they both returned arrays. What find does, or what we've done here, is that it is going to return us one thing. In this case, it's an integer, but it could be anything else. It's going to be one single item. And I think that's really important to note that enumerables don't always just return collections. They can return smaller things. Andrew?
Yeah, I'm sorry. I'm having trouble. Like, just for example, I used maybe the difference is obvious, but like I used each for the FizzBuzz exercise in in the mod 0 pre-work, and it would like functionally, I think it was doing the same thing. So like this is returning just the first even number, but when I was iterating through it with each, if the number was even, it would return this, and if it was odd, it would return that. I don't understand the difference, I guess.
So I think that with FizzBuzz, what you're doing is that you're still going through the each collection. I mean, the entire collection. You're going through that whole numbers. This one stops at the first thing it finds. Like as soon as it hits that 2, it is not going to go to 3, 4, or 5. Whereas with FizzBuzz, you're probably doing like 1 to 100.
Yeah.
Right. So this is finding something. You are still doing a different thing for each item you're going through. You're still going through the entire collection. This will stop as soon as it hits the 2.
Right. Okay.
Right. For FizzBuzz, like after, you hit the 1, like is 3 fizz? Let's just say 3 is fizz, right? So it's going to print out 1, 2, fizz, but it's still going to go to 4. It's still going to go to 5. It's just doing different things. That's the difference between this. This will return. The object is to find a single thing.
And but is it returning just one integer because of the conditional you put in, or because? Yes. Okay, not because of something you did with find.
No, we're not using find. It's still using just each.
Gotcha.
Right. We're showing you what we're doing here is we're showing you what we're doing with each, and then we're going to switch it to find.
Gotcha. Sorry if that was redundant.
No, not redundant. Like, always glad to clarify things. Right.
Thank you.
Yeah. So again, we walk through this array, and the first number it's going to do is that it's going to make this true. It's going to return in whatever. It's going to like return that for us, and we now have access to that one thing. It looks simple, but what we can do is that we can clean this up more by using find. So what I'm going to do is I'm just going to comment this out, and then we're going to re-implement this using find. And it looks like this: numbers dot find do num dot even. And when I run this, it should give me 2. And so again, we've kind of cleaned this up. What find does is that it will walk through the original collection, and as soon as whatever is in the block returns true, it will take whatever it is, whatever thing it's currently on, return that, and we're done. Genevieve?
So is find creating a new array like map does?
No, it is not.
Okay.
It is not creating an array. It returns one thing, whatever that thing is. In this case, it's an integer. It could be a string. It could be whatever. But it is not returning a new collection. It is returning one item.
Okay, perfect. Thank you.
Mm-hmm. Kyle?
So if we wanted to do all of the even numbers, would we use a different method?
Yep, and we're going to talk about that a little bit. Other questions about find so far? And I want to note that like this here is just, we're looking for an even or, I mean, we're just looking for the return value of what is in here. When we refer to this, we refer to this as a block. Like what is between the do and the end enumerable, we refer to as a block. Block is a, you will hear us use the word block a lot. And I don't like the word block because the way we use block in Ruby varies very much on context. In general, the word block means any just bunch of lines of code. When I'm talking about an enumerable, in the context of enumerable, when I say block, I mean the code between the do and the end. Like essentially this line here. That is the block one in the context of enumerable. But in general, a block is a bunch of code. I will try to avoid using the term block as a bunch of code. When I use the word block, I'm generally speaking about enumerable and a bunch of code, the center part of enumerable, just so we're kind of clear, all on the same page about how I'm communicating. And again, if I'm not being specific enough for you, if you need clarification on how I'm using term, 100% please have me pause and clarify. All right, any other questions about find? One thing I do want to note is that find is also called detect. And because we're going to get into like what is, when we did the independent challenge review today, Megan and Bob talked a little about how things are truthy, how assert looks for things that are not nil. And the idea is that any value that is not false or nil is truthy. So you can kind of use find as a kind of detect, because if there is an even number in this collection, it will return something, and something is truthy. And you could check to see like, is this something? It is something we know that there is an even number in there. If this has, let's say this is like that. If I change the thing to that, when find finds nothing, it will return a nil, and that is what's considered falsy, and falsy is either false or nil. So you could use a detect to kind of like, hey, is there something in here that's even? Is there something in here that matches my thing? And you don't really care what it is that it found. You just know that it does have this match, and that's why some people also use find as a detect. Like you are detecting that there is something in here that matches my condition. Does that make sense? But honestly, I never used the detect syntax, because find in my mind is like, hey, I'm just finding a thing. Makes sense. Doug?
So detect is another enumerable that we can use, though.
No, detect detect is this. You could use detect or find interchangeably the same way that we can use map or collect interchangeably. They're aliases for each other.
Okay, so detect will also return the value. It won't return true or false.
Yeah, they are exactly the same thing. Find
Gotcha.
and detect are exactly the same. They're just different names, in the same way that map and collect were the same way. So if I did this, let me change this back to the 2, 2, 4. That's right. Yeah. I'm going to change this to detect. Still finds it. Right. And just like how I prove that this is finding the first one, I'm going to change to that. And so now we should get 4, right? Because 4 is also, let me change this here to prove it, right? Like, so I made this array the way it is to show that it's going to find the first even, which is 4, but not all the evens, because that, or not the last, or all the evens, which is 6. So this should give me 4. Yep, and it does. Cool. All right. So what I'd like you to do is like to take 5 minutes to practice. I'm going to pull up Slack and paste some stuff into Slack. Bum, 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 bum. We have an array of the Kennedy sisters. I would like you to find the first sister whose name is over 4 letters in length. And I'd like you to do this using .each. So using .each, first sister whose name is over 4 letters in length. Let's take 5 minutes. Let's take till 11:11. All right, it's 11:11. Jake, would you mind sharing us what you got?
Sure. Can you all see the screen?
Yep.
Cool. Okay, so I just did interruple. Just copy that out from here. Sisters is here. Sisters dot each do sister. If the sister is greater than 4, return sister.
Cool. Fantastic. Awesome. That's
out the results.
right on. Excellent.
Yep.
Cool. All right. So let's take another 5 minutes. Now let's modify that to use .find or .detect instead of each. Let's take till 11:15. All right. Jenny, would you mind sharing your screen? Show us what you have.
Yep, I can do that. Can you see my atom?
Yep.
Okay, so I just changed sisters.each do to be sisters.find do.
Cool.
And then checked if the name length was greater than 4.
Awesome. Fantastic. Yeah. And that's great. Cool. It is 11:16. Let's take a break till 11:22. During this time, when we come back, we'll we'll field some questions about find. Let's take a break. We'll see you at 11:22. All right, welcome back. I think my biggest fear is that New Year's Eve is gonna hit midnight instead of the clock around midnight will be like 11:60, and this year will never end. So questions. Let's open up the questions for find, detect. Anyone come up with anything they want to talk about in particular over the break? Can we move on? Is it okay to move on? All right. So the next piece that we're going to, the last thing we're going to talk about today is find all and select. Dun, dun, dun. And I think that knowing that find grabs one thing, we can kind of draw the conclusion that find all grabs all the things. And so find grabs one matching thing out of an array. And what if we wanted to grab all the things out of the array? We would do something like this using .each. The main difference here is that instead of returning whenever we find a match, every single time we find that match, we're going to shovel it into the accumulator. Like this kind of follows that pattern that we've seen before. Instead of, I think the big difference here is instead of collecting a thing, like we're going to have this conditional in there. and we have that result num gets shoveled as a result if the number is odd. You can also break this out to do something like if num dot odd result num. That also works exactly the same way. Those two are interchangeable. We just kind of use this syntax usually because it's a little shorter and a little easier to read. And so this is great, but like the kind of idea is that as we're using these enumerables, as we're kind of going through, like the kind of big pictures that we use, like these are very common patterns of things that we may want to do in Ruby, right? When we're programming, hey, you know what? Odds are at some point we want to find one thing out of a collection. Odds are we're going to want to find everything that matches a certain criteria in our collection. And so the idea is these enumerables is that, like I said, we are going to go ahead and streamline all of these processes. Right? We want our code to be clean, and Ruby gives us these methods that kind of clean things up, and they use this term called syntactic sugar, where it's just like, yeah, this is real easy to type out, looks clean, makes sense. You look at it, and like, yeah, I get what's happening, and so we can kind of change things. And like one of the big things that I think that enumerables do to give that syntactic sugar over .each is that like whenever we use .each, we have to make that collector variable, and we got to put the things inside there, and that's irritating because if you are like me, you've seen me type, that's another opportunity for you to make a mistake. So we can modify this in order to change this into a way that we don't have to do that. So I'm going to comment that out, and we're going to convert this to using find all instead. Numbers, oops. Nope, forgot to. Yeah. This needs to be commented out as well. Numbers, yeah. Numbers dot find all do num dot odd, and don't need that there. And what this does is that if I run this. Let's do puts all the odds. This should return me the 135. 135. And find all is also known as select in the same way that detect is the alias for find. Personally, I just use find and find all because it's very clear what it does. But whenever I see select detect, I always have to think like which one is which again. I don't remember which one's which. So I just never used select detect because I will, not only will I mix that up in my mind, I'll convince myself when I have it right that I've actually mixed up my mind, and I'll, like switch it again. Kind of like the poison scene in The Princess Bride. Like you just keep it switching around because you don't trust yourself ever, and then you lose. Also, kind of like plugging a USB port in. No matter what you do, the first time you have whatever side you plug it in, that's the wrong side. Like you always got to flip it at least 3 times before you get it right. I don't know why, but I don't make the rules. You always plug in a USB thing 3 times before it works. Questions about find all so far? Find all / select. It's pretty. The thing I think that as we start to learn more and more enumerables, the understanding, the ease at which you understand them goes up and up, because we've seen like there is this pattern that they all follow, right? Map returns this collection. Find, well, that returns one thing because we expect to return one thing. And I think the difference here, that I think the good thing to note here is that with find all, it is returning an array. Like we are getting an array back because it is finding us more than one thing. Kyle?
Could you give us an example where you combine 2 of the previous methods that you just used? Like in the same sort of method? Because
what do you mean by combine, I guess is my question.
I mean, so it's sort of like you do an original query for a set of data, and then with that return set of data, you do another sort of query on it.
Yeah. Let me. let's do this. Make a new file. Let me use this example that we've been working on. Oh, put me on the spot. I'm trying to come up with like a contrived example I can show you that works and is clear. Okay, I got it. This is going to be weird, but like we're going to do it. I'm going to change Gene's name to Keen. Just so this example works. Let's say I wanted to get all of the sisters who name started with K and were less than 5 letters in length. I would do K's equal sisters dot find all do sister dot sister 0. You could do this with strings. You could use a bracket notation to grab the first letter. I'm pretty sure you can do that. I should probably make sure. Make sure I'm not telling myself lies. Yes, that works. Oops, that is not K. Right? So this will give me all the sisters whose names start with K. And then I do K's dot, name equal K's dot find do sister, where sister dot length is less than 5. What's the name? That should give me Keen. That is one way I do it. That is one way you could like kind of chain things. Oops. Right, but the thing is that like if we're trying to find the K's, the easier way to do this would be like to simply put that here. K and sister dot length is less than 5. I'd probably do that instead and not have to do this, like not have to go through the thing again. But the thing is that like the thing we want to note here is that this will return us an array with a single item in it, where this will return us just the item. So like when we're doing things like this, be very cognizant of what these enumerables return, what object they return, because I think you'll like, I think a common error is that people will get these mixed up and like, oh no, this is, I'm looking for, I'm looking for a collection of things rather than one. I think that this is very something that you should watch out for in your independent challenges. Like when we tell you we want this method to return this, are we asking it as like a string? Do we want it as a collection of strings in an array? Look for data types. The data types that things are and the data types of stuff we're asking for is like super, super important. Like do not like overlook that. Like it is kind of hard to with just the 3 new enumerables we've learned about today, it's kind of hard to come up with an example that is like meaningful. One thing that we could potentially do is like, what if I wanted, oh, here's a good one. I found a better one. I just came up with one, right? Let's do this. Let's say I wanted, let me change this to Jean because this Keen is bothering me. I wanted all the sisters whose names were longer than 4 letters capitalized, right? So I would do longer equal sisters dot find all do sister dot length equal greater than 4 end, and then I would do capitalized equal longer dot map do sister dot uppercase, not I want uppercase, not capitalized. They're already capitalized. Sorry. That, so we'll call this like that, and then we can do what's uppercase. And if I've done this correctly, it is going to be Kathleen, Eunice, and Patricia, all in caps. There we go. That's better. That's more that this pattern here of taking the contents, taking the return value of one enumerable and then running that into through another enumerable is something you're going to do a lot, like a lot. And this is like I think this is a genuine example that kind of makes sense of something that you might actually do.
So when we do that, would we put those in the same method?
To start, I would eventually refactor them out to separate methods, because the idea is that if we
just call each method within the other method. Okay.
Yeah.
Thank you.
Yeah. The big picture is that like a method should just be responsible for one thing. And let's say that this was in a method, right? This would be doing 3 things. It would be finding the appropriate sisters. It would be upcasing the sisters, and it would be printing out to the screen. That's 3 separate things it's doing. Each method should be doing responsible for one thing. It's a thing called single responsibility principle. We want our methods to be small and to do as little as possible, because this gives us the flexibility to reuse our code, right? Like there is never going to be another situation where you are going to need to find all the sisters long with 4 letters in length and upcase their names. However, there may be a situation where you need to find all the sisters of greater than 4 letters in length. And separately, there may be a situation where you just need everything in a method upcased, right? Like those seems reusable. The whole thing together, like no, you're never going to reuse that again. Cool. All right. Dun, 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 dun. All right. So next up is let me get this ready. Let's take 5 minutes. Using .each, write code that will return the numbers that are divisible by 3. Little hint, you would use modulo much like you did in FizzBuzz. So let's take until 11:42. All right, it's 11:42. Who wants to share their screen? Soliciting volunteers. Angel, let's go ahead and share your screen. Do I need to stop sharing? There we go.
Yes. Okay. I think this is the right screen. So here, let me make this bigger.
Okay, walk us through it.
Okay, so right here, I create a result array, and then I iterate through each number, and then it goes to number, for example, would be 1. And then I check to see if 1 modulus 0 equals 3. And then if that returns true, then I insert num into the result array. And then once that is done iterating, I return result and then print it out.
Fantastic. Awesome.
And I
Thank you.
get 369.
Yep, those are the numbers. Cool. Awesome. Now let's take 5 and do that again using find all. And we'll take you 5 minutes to do that at 11:48. All right, who wants to share what they have? Will?
All right. Okay. So where's my cursor? Is that showing up for everyone?
I see your screen, but I don't see a cursor.
Okay, yeah.
Oh, there we go.
There it is. All right, so it's just replacing the other one. So I'm using select because I'm actually more comfortable with it, but
sure,
it should be the same. So I'm just taking each number in the array, checking to see if the remainder is 0 divided by 3, and that's it.
Cool. Fantastic. Thank you for sharing. Awesome. Kind of want to open up to questions about find all. Jeremiah?
Oh, no, sorry. I was trying to volunteer. I need to lower that.
Okay. Any questions about find all / select?
What would happen if you don't have an empty array to shove that into with each?
Nothing. Each would just return the original collection. So if you're trying to refer to a variable you don't have an access to or doesn't exist, it's going to give you the no local variable error. That is, if you don't have that, then it's just going to return the original collection. Cool. Other questions about find all? So this is kind of like the first the first class we're going to have enumerables. There are so many enumerables. They keep adding more. So we are not going to teach you all the enumerables. That's going to be up to you to kind of explore and find more appropriate ones. We're going to talk about some of them. I'm pretty sure we have another class talking about a different set of enumerables to show you some different kind of form of enumerables. But it's going to be up to you to kind of like go through your enumerables on your own and find the appropriate ones to use. I think it's important to note is that like we've had you do everything that these enumerables have done with .each, because the idea here is that if you don't know of a specific enumeral for the job, like you could do it like by hand. Like you could do essentially anything by each using .each. The idea is that .each is a good place to start with, but like by the end, it's, and we want to see you moving towards the more purpose-built enumerables and finding those and using them as you as you as you kind of progress in your career. I would say that like it is well worth your time. Just go through the enumeral documentation and just take a look like, hey, what can I do with the enumerables? What can they do for me? Thankfully, a lot of the enumerables, they sound like what they do. Like we've shown that today with find. Find's one thing. Find all. Finds all the thing. Map, it goes over every single thing in a collection. And this is a pattern that holds true throughout the entire thing. To practice enumerables in your Ruby exercises, there is an enumerables section, and going through that is going to get you like super comfortable with using enumerables. That is all I have for you today. Any questions about anything from this morning at all? We got a bit of time. Kyle?
Do you have a favorite enumerable that you recommend we check out that's like fun and clever?
Fun. Yeah. I think that reduce / inject is super powerful, but I think that it runs the danger of, I think so. I am very opinionated when it comes to code in terms that I think that we should be writing code for clarity first, like to be compassionate to like the next person, be it, you know, another engineer or yourself 6 months down the road. And I think that a common trap that people new to programming get into, and like I have done this as well, is that we you get into this thing of you have a new tool, you try to use that new tool to do everything, and it's not the best tool to do everything. I super think that reduce is like super powerful, but it is not appropriate to be used in times where something else could do it better. Like reduce can duplicate the functionality of any enumerable, much like each can. And so the idea is like, what I'll see, I'm like, I'll actually like, why did you use reduce here when a find all will do the same thing? Right? There's like use cases when you would use it in use cases you don't. And I think the same thing follows for like, I think that newer programmers think that it's really cool to do things in as few as lines of code as possible. I'm like, when you do that, it just becomes an unreadable mess. I feel this way about like using ternaries. I think ternaries are terrible because they're just so much harder to read than an if-then statement. People using the lambda proc syntax for using enumerables, like the ampersand symbol syntax, like I think that's terrible. Like I think it just helps no one understand what's happening. Single line syntax for enumerables I think is not good as well. Kind of like the big picture is that like if you're using multiple different kinds of syntax to kind of communicate the same thing in code, like why stick to one syntax and use that everywhere? And then this way, like we don't have to use that context switching. I think that like one of my priorities in writing code is that I try to avoid making people think too many times. Like this whole idea is I think that like every person has like a limited amount of cognitive power per day, right? Just like your energy, like, and like why are we making other people jump through extra hoops to make ourselves feel good about how clever we were? I think, you know, in general, clever code's bad code. I think that real world examples, like remember when Zuckerberg had that phase where he only wore like the same hoodie and jeans every day? I mean, like that's because you don't have to think about what clothes you're going to pick that day. Like it's just one less decision you have to make. Like when Obama was president, never picked out his own clothes. Like why? Like got bigger decisions to make. Like save your energy for like the important decisions. And like like for me, I have a stack of like all these turning t-shirts every day. Just pull the top one off. Like I don't have to like I'm not sitting there for like 5 minutes trying to pick like, oh, what t-shirt am I going to wear today? I think the worst one is like, no, today's not a Taylor Swift t-shirt kind of day. I'll wear this other one. But like that's as far as my t-shirt decision making goes. So that's like kind of like my plan. Doug?
So mentioning something about new coders liking to make their code as short as possible, can you talk a little bit more about finding a balance between concise short code versus clear code?
Let me do this. Can y'all see my screen? No, wait. Maybe? Yes? Okay, good. No, 5 rules. Wait, 4, 5? I forget. They're rules. She's rules. In general, I abide by these rules. Classes can be no longer than 100 lines of code. Methods can be no longer than 5 lines of code. 5 is where I'll generally draw a limit. We do not expect you to hit 5. I think that if you're keeping it below 8 or so, that's pretty good. 7 or 8. And as time goes better, you shorten up. But I think that like these are just metrics. Metrics to measure something. And what I would say is that if your methods are doing one thing, that's short, that's fine. And how do you determine if a method is doing one thing? And like, I've kind of spoken to you about, I always say things out loud to myself. So what I'll do is that when I have a method that I feel like, is this doing too much? I will just look at the method and I will say out loud what it's doing. If I use the word and a couple of times, that's a pretty clear indication I need to, like, it's doing too much, I need to break it apart. Right? I think that like never underestimate the power of saying something out loud or writing it down in words on a piece of paper. Like those are going to be like your most powerful tools. Like when I'm working, I always have either a notebook or a couple of pieces of paper on my desk with a pen next to me to make notes and to like write things out. Always. That is without fail. I always have that because like I think that programming is often looked at as like a mathematical scientific endeavor. Like it's more language, it's more art than you think. I think it's important to kind of like make sure that what you're doing crosses those lines as much as possible because you're engaging different parts of your brain and trying to do the best job you can. Cool. Kyle, is that a new question or the same old hand as before?
Oh, sorry, that's the same old hand.
Okay, cool. Anything else?
I actually have one more question.
Sure.
Approximately what % of the time that we spend on like our project per se should be spent on refactoring? And at what point, like, do you recommend refactoring at the end of each iteration and then moving on to the next one?
That's one great question. Two very hard question. I think it's important. It's very subjective, and I think it's very. The thing is that we want you to write good code because that's what's important, but we also want you to hit the learning goals that we want you to hit. Right. So, like, I think that from an instructional standpoint, I would be much as a staff, as a whole, all of us, Bob, Megan, would rather see a project that is maybe missing a couple of methods, but is really, really well written, rather than something that hits iteration 4, but it's absolute garbage, like the entire way through. I will say that out of all the rubrics on your project, completion is the least important to me. Because if you do like 90% of the project and that 90% that you did do is like super, super good, that is showing me like you know what you're doing. You could probably hit that last 10% with like maybe a couple hours of work, not that big a deal. However, if you turn in something that, yes, it does work, yes, you've done all the things, but it's just like a rat's nest of code, like that is not something that I would want to see. That being said, if you just do iteration 1 and that's perfect, like, no, that's a separate problem. You know, when I'm saying that completion is least important, like you still need to get a good majority of things done, right? Because like the harder, more interesting problems are like in iterations 2, 3. So like when you're refactoring it's different for everyone. Like it's different for everyone in terms of like, I don't know how much time I have left. It depends on how much time you have left to go to the project. When's it due? If I'm working on my own stuff, I have the level of experience where I will write code that is pretty well refactored to start with. And any modifications I would make are not huge refactors. Like I've seen the patterns long enough and you'll get there. Like I know exactly where I want to go. Like I'll, before I even write the code, I'm already refactoring in my head of how I want to go. So like that is a point you'll get to at you'll get there, just not right away. I think it really depends on how much time you have left in the project. I would say probably at the end of each iteration, I would do a quick look through to see what I can refactor and see if there's any low hanging fruit. I would not go into a major refactor with the project not completed. But again, like lots of variables, lots of situations. Cool. All right, that is it. Enjoy your lunch. We'll see you at 1. I want to mention that the schedules for the project check-ins are up on the calendar, and the links for that are up. So you'll see, we'll meet you in small groups to go over your projects a little bit at 2. Enjoy your lunch. Goodbye.
Really quick, we're meeting at 2, not at 1.
Your class is at 1. Your project check-ins are at 2.
Oh, gotcha. Thank you.